Okay, we'll start another chapter. Metal forming. Shape changing of most material can be accomplished with the material in one of several different forms or states. So this is plastic deformation. When the metal is in plastic stage, you have to change the shape. Effect on temperature and deformation rate. Energy form used to affect shape changes and may vary. So you need some energy to do this thing. Sometime if it is ductile, okay. Process effect on the properties. Not going too much to this. Hello again, somebody. Hello, Mr. Beluchina. Net step manufacturing, auxiliary steps. The completion of the product for final use generally includes the various finishing procedures. Apart from the basic shape changing process, the dimensions and properties that are produced by any process that is subject to variation. In practically all cases, some non-destructive inspection is necessary for controlling this process for ensuring that final product meets certain specification. Bulk deformation process. Some serious limitation of casting process. When casting is there, you have less tensile, means it is having compression strength, but tensile, no. The problems associated with casting, thin sheets you cannot do. And even the thickness of 25 or more, the problem of obtaining uniform thickness and properties over large areas are problem. Deformation improve properties. So because deformation you are doing from wrought metals, not from castings. The deformation process, cold or hot, can often be used to provide the double benefit of property improvement and shape changing at the same time. Even with higher cost, the value of improved properties is so great that approximately 80% of iron-based metals are finished processed as wrought material. Most output requires further processing. Typical products of this class include foil for package operation, cold rolled sheets for press working operation, bar stock for machine parts, and rough rolled billets for forging operation. End product by secondary deformation. The second group of deformation operation involves those product oriented, and we are usually performed on a smaller scale in plants fabricating finished products. Few mills, many fabricators. Forging is three-dimensional. In mean operation, the primary shape control is over uniform cross-sectional shape of a product. In process operation of sheet metal, the thickness of metal is directly controlled by operation. Forging operation exhibit three-dimensional control of the shape. For the most of this operation, the final shape of product is forged, and further finishing operation are necessary only because the accuracy limitation of the process. Forging need dies may be open or closed. High compressive loads required. NDT of forging. So ultrasonic testing is used principally for detection of internal discontinuities, while magnetic particle and penetrant methods are used for detecting surface discontinuities. Open die forging, blacksmithing, a manual process or mechanical process nowadays with a hammer, mechanical hammer, power assist for heavy work. Closed die forming. Closed die is expensive. Matched metal dies like pattern for casting must be made for each shape to be forged and become feasible only when the tooling investment can be divided among a sufficiently large number of parts. Forging and casting are competitive. Material quality improved by forging. Sequential steps necessary. Offsetting, enlarging the cross section by pressure from the end. Drawing, reducing the cross section stuck throughout. Fullering, reducing the cross section of the stock between the ends. Edging, distributing the metal to the general counter of the finished stock. Blocking, shaping to rough finish from without detail. Excess metal ensures die filling. Let's go through it. Even with the pre-shaping operation, it is necessary to provide some excess metal to ensure that all parts of the final die cavity are filled. The dies are constructed so that in the closed position, a space is left at the parting line through which the excess metal is forced into a gutter. This excess metal, called flash, is actually part of forging and must be removed in a secondary operation, generally by trimming in a shearing type of die. Steel drop forged. Nasser Al-Rashid. Can you mute yourself? Thank you. Steel drop forged, non-ferrous materials press forged, but steel is drop forged. Fast and accurate but high setup cost. Forging with progressive application of pressure. A basic forging process with a forge press tool. It is continuously hammering upside, and lastly it is like this, and that you find this object and there is the flash. Roll forging. Roll forging progressively reduces cross section. Rolling operation, hot rolling or cold rolling. So hot rolling is the common initial operation. So while the metal is hot above AC3, because we already read iron carbon diagram, so whoever not, they have to go for that. So still above the ingot or the billet, you can say. From ingot we are getting blooms and all, and then hot rolling for plates. So that is to be hot preheat to AC3 temperature. Then it can be go for hot rolling. So mill work, hot rolling or cold rolling. or can be extruded tubing and shapes, rolling a flat form or different forms, bloom slab billets, and then go for plates. So these sections are bigger, so you have to go for again heat it. Without heating it cannot go for the next stage. Rods, structural shapes and pipes. Extrusion is tubing and shapes. Cold rolling, so flat and forms. Strip sheets, bar, rod, wire and pipe. If ductility is there, so cold forming may be possible. Process and product type primary mills. Blooms, slabs and billets. Blooms and billets are approximately square cross-section of large and small size, respectively, and slabs are rectangular shape. Thickness reduction by compression. Blooming mill reversible. At the blooming mill, where the first deformation work is done on the material, the cast ingot is rolled back. This ingot is directly from the liquid metal. We prepare the ingot, then we heat this ingot to AC3, then roll back and forth between the rolls or continuously through the sets of strands of rolls are brought closer together to control the rate of reduction and establish new dimensions. Mechanical manipulators are used to turn the block, or additional vertical rolls are used to making an approximately square cross-section bloom or rectangular slab that may be as per 18 to 21 meters, 60 or 70 foot long. And they are sized at the end. There are shearings. They can shear at the both sides to size it. Various arrangements of rolls and rolling strands, backup rolls, and support to contact rolls, purple, leave it. You can go through the book. Casting got discontinuity is removed. So what we have in casting got discontinuities? We have maybe porosity or piping, shrinkage, poor quality metal. So we have to remove 1/3 of the bloom. Cut away to eliminate major portion of the impurity. Really not the bloom, it should be from the ingot. Continuous casting eliminates ingots. So there is another process called continuous casting. You can directly cast plate from or bloom directly from liquid metal. So that is costly, but the advantage gain is elimination of ingot cropping. Billets smaller than blooms, so the size is smaller. Hammer forging for special cases. Continuous hot rolling. The blooming slabbing mill. If you go, you can see continuous hot rolling. Surface oxidation is a problem, and surface finish is a problem. Because of oxidation, there is everything going inside. Will become oxide, scale, all things can go inside. So finishing is very much problem here. Cold finishing is a good finishing process. Limited accuracy for hot rolling because of difference in working temperature affecting shrinkage, differences in oxidation depths, and more rapid wear on the rolls. Dimensions are more difficult to hold in hot rolling process than when finishing is done cold. Property is changed by cold working. The properties will improve by this. Materials that are treated in this way must have sufficient ductility at the beginning but the ductility is reduced as the hardness, yield strength, and tensile strength are increased as the deformation progresses. Flat products means plates, strip, sheet, plate, or bar. A variety of bar shapes and rolled, square, rectangular, round, hexagonal, and other shapes. Tubes and pipe making. So pipe and tubing mill products. They are not by rolling. Rolling is only for plate or plate type products. Conventional 4 high or cold reduction method, continuous. Pipe is by welding bell. We'll see what is welding bell. Pipe by roll welding. So either you can draw bench for cold reduction bar. And shaping and welding a pipe in a welding bell. This is called welding bell. You can just draw through it. So these two sides of the plate, this strip will combine together, then weld it. Resistance welding sometimes. Continuous process of butt welding in the pipe. Depends how you choose for welding. Resistance welded tubings or pipes. Light gauge steel tubing in a size up to this 40 centimeter. Diameter may be produced by resistance welding. Some pipe welded with filler metals. A large size from about 6 inch to above. There's so many things for welded pipes, spiral welded pipes. There even argon TIG welding process is there. When you go to piping mill, you can find many things. But there is something seamless piping or tubing. So seamless means there is no welding. This seamless tubing refers to a tubular product that is made without welding. Yeah, resistance welding tubing. Sorry. Sizing of seamless tubing. Seamless tubing is useful for machine parts. Seamless pipe is for good pressure. It can sustain good pressure because if you have welding, there is the problem with welding. So that is the weakest point. So if you have seamless, it can sustain more pressure. Some tubing may be press operation. In cupping operation, seamless tubing is produced by press type operation similar to cell drawing. There are several processes. This is same roll. It is called piercing. There is a mandrel from the roll products like roll bars. Can just pierce through. While rotating, it is pushing through this, and you can get a pipe. Electric welding of a large pipe. Schematics. Entity of seamless tubing. So there are eddy current. There are mainly eddy current we are doing. And pressure testing. That's all. Perfect welds is difficult. Extrusion. Extrusion is a high energy process used extensively for non-ferrous, but many times for ferrous also. flexible process but limited to uniform cross section. Sorry, 1 minute. Drawing involves multiple stress. So drawing means that is extrusion. You can push from a ram and then it is the extruded bar through the die. So when you are pushing by this and directly pushing this liquid metal to form something, extruded tubing or something, sheathed cable, that is called primary, this direct extrusion. If you're pressing through the mandrel to this liquid metal and your things going out, that is example of reverse extrusion. Recrystallization may reduce number of steps. An operation might be accomplished with single redraw if part were reheated for recrystallization. After the first draw to restore the original locality and permit a greater reduction in the first redrawing operation, the actual choice of single draw, two draw, or opposed to a single draw recrystallization needs. So that is for that you have to go for AC3 and go for keeping there for recrystallization, normalizing. All things are there. Single form used in stretch forming. So this is stretch forming, punching, punch for cell drawing, spinning. Spinning, versatile, low cost but low quality process, one of the oldest production method for cylindrically drawn shapes or spinning. Swaging, rotary swaging. Machines of this type are used most frequently for reducing ends of bars, tube, wire stroke so that it may be started through a die for a drawing operation. Rotary swaging. Sheet metal forming process. Most metal consumer goods and presswork. Sheet metal characteristic. Ductility is essential. Applied load cause material failure. Special tools. High cost tooling aligned in die cost. Shearing is a cutting operation. Shearing is for variety of purposes. You can say cutting or shearing. Produce an external shape which may be either finished shape or raw material for some other operation. Remove part of the material or cut in such a way that the operating opening or indentation is produced, or remove material that are necessarily left on the part from some other operation. Categories. Shearing operation may be grouped into three categories: shearing, slitting, cut-off, parting, dinking, blanking. A simple die set, blanking, hole making operation, punching, slotting, perforating, semi-notching, notching, lancing, piercing, finished operation, trimming, shaving, straight line shearing for plate cutting and all, that is straight line cutting. Slitting, figure 7.21 shows rotary slitting. Bending of seat and plate. Ductility required for bending. Slitting and shearing. Shear cuts. Outside radius is distorted because of bending. Forming, by strict definition, bending would include only operation in which the plastic flow is confined to a narrow straight line region where the bend is made. This is also like this figure indicates the nature of deformation taking place in a bend. The metal on the inside of the radius is subjected to high compressive stress and outside is high tensile stress. This is a bend. During bending, compressive stress is tensile stress during bending. Roll forming, alternative to conventional bending. Roll, you can roll. For tubing, that is okay. Miscellaneous sheet metal forming process. Explosive forming. The most highly developed from this method is explosive forming shown in the figure this. So nowadays, there is a corrosion resistance material, so it has to be attached with the plate. So then put explosive and combine this together with vacuum and explosion. You can combine these two together to get corrosion resistance layer. Two methods of explosive forming: explosive removed from the workpiece, explosive within closed die. So anyone can be. Electrical energy methods. Similar methods are based on sudden release of electrical energy stored in banks of condensers. In one method, spark is created between two electrodes while they are submerged in water or air near to the workpiece. In second method, a high current discharge through the relatively small diameter wire result in vaporization of the wire. In either case, a shock wave is created that is transfer energy to the workpiece. One of the newer methods involves the release of stored electrical energy through a coil near the workpiece. As shown 7.24, the rapidly created magnetic field induces eddy current within a conductive, though not necessarily ferromagnetic workpiece, which set up fields that interact with the coil fields and create high force. Okay, how much time is there? So you have any questions you can ask?